Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera. Okay, today we will continue our discussion on chapter 4, which is sinusoidal steady state analysis. Okay, so our subtopic for today actually is voltage and current divider rules. Okay, so this is our learning outcome for this subtopic. So at the end of this subtopic, you should be able to apply voltage divider rule and current divider rule in steady state AC circuit analysis. Okay, this is our main content of this topic. So number one, we will discuss and derive the voltage divider rule, and number two, we will discuss and derive voltage current divider rule. Okay, so first of all, we will discuss about voltage divider rule. Okay, so why we need voltage divider rule? Okay, why we need voltage divider rule? Okay, basically voltage divider rule is a shortcut method. Okay, shortcut method for determining the voltage drop across impedance within series circuit. Okay, let's say you have a series circuit, voltage supply V connected with Z1, Z2, Z3 until Zn in series. So we can determine V1, V2, or we can say a voltage across each impedance, okay, by using voltage divider rule. So the question is how to derive the equation of V1, V2, okay, according to the voltage divider rule. Okay, so first of all, we try to derive the equation of voltage divider rule. Okay, let's say we have a series circuit. Okay, so our V supply, which is V equal to I, because current through Z1 equal to current through Z2 until current through Zn. So we have I times with total Z. Okay, is it correct? Because V equal to IZ1 plus IZ2 plus until IZN. So this is the equation of V. Okay, so how to determine current? Okay, current for each element, current through Z1 equal to current through Z2 in series. Is it correct? So we can write that I equal to I1, which is V1 over Z1, equal to I2, V2 over Z2, and so on. In equal to Vn over Zn. So we can replace this equation I by this current. Okay, let's say V1 over Z1. Okay, for determine voltage across Z1. Okay, so we have a V equal to V1 over Z1 times by total Z. Okay, so how to determine voltage across Z1? Okay, voltage across Z1 means V1. How to determine V1? So we can rearrange this equation. Okay, rearrange this equation. V1 equal to Z1 divided by total Z. Okay, total Z, summation of Z1 plus Z2 plus Z3 until Zn times V supply. Okay, so you can get V1. Okay, so you can determine voltage across Z1. Okay, equal to Z1 divided by total Z times V. Okay, similarly to the voltage across Z2. Okay, voltage across Z2 equal to V2. V2 equal to, okay, Z2 divided by total Z times V. Okay, so this is the equation of voltage divider rule. So we can generalize this equation in order to find the voltage drop across impedance Zi. For example, we can write, so we can conclude that Vi equal to Zi divided by total Z times V. Okay, so by using voltage divider, we no need to calculate current to determine voltage. Okay, this is the main advantage of voltage divider rule. Okay, so the voltage divider rule is very useful in circuit analysis because it allows us to determine voltage drop across an impedance within a series circuit without okay, without having to find the current first. Okay, this is the main the main advantage of the voltage divider rule. Okay, look at to the simple example. Let's say we have a V voltage supply across two impedances Z1 and Z2. So the question is, what is the value of V1 and V2? Okay, so by using voltage divider rule, we have a supply voltage V1, okay, voltage across Z1 equal to Z1 divided by total Z in series. Total Z in series, in this case Z1 plus Z2. Okay, similarly to V2, V2 equal to Z2 divided by total Z times our total V or V supply. Okay, is it clear? Okay, so look at to the example 1. Okay, how to apply voltage divider rule. Okay, the question is determine the VLT and IT. Okay, given source voltage, then you need to determine VLT. Okay, so you can apply voltage divider rule by determining VL. You can find VL by using voltage divider rule. Okay, in order to solve this problem, first of all, you need to transfer from time domain to phasor domain. You need to draw the phasor domain circuit. This is a time domain circuit. Okay, look at to the Vs. Vs equal to 5 sine omega t or tan t. You need to convert to cos, equal to 5 cos tan t minus 90 degree. Okay, that's the conversion. So you can determine the phasor representation for voltage equal to 5 angle minus 90, and then you can determine the ZL. ZL equal to J omega L. Okay, you can get ZL. This is a ZL. ZR equal to R itself, angle 0 ohms. And then you need to draw the phasor circuit. This is a phasor circuit. Okay, V, ZR, and ZL. So next, you can determine VL by applying voltage divider rule. Okay, so VL, in order to determine VL, according to the voltage divider rule, ZL, which is ZL divided by total Z times V supply. Then you can get voltage across VL. Okay, question number 1. Then question number 2, ask you to calculate current through ZR and ZL. So please remember you have a VL and then you have a ZL. You can determine current IL, which is IL equal to I in series circuit. So I equal to VL over ZL. VL, you have a VL here, and then you divided by ZL, so you can get current. Okay, so you have a VL and I in phasor domain, so you can convert or you can transfer to the time domain. Okay, this is a magnitude, this is a phase angle, which is omega equal to supply angular frequency. Okay, supply omega. Okay, and then you can determine IT, small it, magnitude, and angle. Okay, that's the method, that's the steps on how to apply the voltage divider rule. Okay, from this you can determine phasor diagram. You can draw the phasor diagram. Okay, you can try by your own. Draw the phasor diagram of VL and I. Okay. Okay, next, look at to example number 2. Okay, based on the circuit below, okay, find the voltage VCT in steady state. Okay, the question is ask you to determine the voltage across this C. Okay, VCT. Number 2, find the phasor current through each element. Oh, okay, they ask you, this question asks you to determine the current through IC, current through R, and the current through L. The last one, construct a phasor diagram. Okay, construct a phasor diagram showing the current for each element and source voltage. Okay, given time domain circuit, so what you need to do? You need to draw the phasor domain circuit. So, okay, please bear in mind we have a Vs in sine sinusoidal 10 sine omega t. So you need to convert to cos equal to, okay, please take note, Vs equal to 10 sine omega t minus 90 degree. Please take note, Okay, convert to cos equal to 10 cos omega t minus 90 degree. So draw the phasor diagram first. Phasor circuit diagram. Okay, Vs you convert to cos, Vs sine you convert to cos minus 90 degree. Then you can get a Vs in phasor form. Okay. After that, you can determine the impedance for each element. ZL equal to J omega L. This is a ZL. Okay, J omega L. Make sure you draw the circuit. Please draw the circuit. Vs, ZL, and R equal to R, angle 0. And then ZC equal to 1 over J omega C. Okay, please remember 1 over J omega C, or and then you can use your calculator. Why this is minus J? Because 1 over J equal to minus J. Okay, you can use your calculator and then you can get ZC. And then label here. You need to write here. ZC, ZL, and R. So next, you can apply voltage divider rule for determining VC. What is the VC? How to determine VC? VC, voltage across capacitor, equal to voltage across R, because this is in one node. Correct? In one node. So what you need to do? You need to combine R parallel with ZC. Okay, you need to combine R parallel with ZC because we know that voltage across R equal to voltage across ZC. Okay, because they are in one node. Okay, this is our, let's say we call it a ZA. Let's say we call it a ZA. So our ZA equal to 100 in parallel with minus J100, and then you can use your calculator, determine the parallel impedance. You can get the ZA. Okay, you can get ZA. How to determine ZA? This Z times this one divided by 100 plus minus J100 equal to this one. Or you can indirectly use your calculator, 100 inverse plus 100 plus in bracket minus 100i inverse, answer, and then you inverse again, and then you can get this one lah. Okay, just use your calculator. Then when you have a ZA, kamu dah ada ZA kan? Okay, so we have a series circuit. Okay, then you can easily determine VC by using voltage divider rule. So VC equal to ZA. Okay, VC across ZA. So ZA divided by ZA plus this ZL times input voltage. Then you can get a voltage across C. Okay, clear? So from polar form, you can convert to time domain. Okay, 10 cos omega t plus phase angle. Okay. Okay, next, number 2, find the phasor current through each element. Okay, current. Determine current through each element. So you have a VC equal to VR. So IC equal to VC divided by ZC. You can determine IC. So IR equal to VR divided by R. Okay, VR, in this case, VR equal to VC, parallel. So VC divided by R. So you can get IR. Okay, element R, element C. Then you can determine current through the L. Okay, by using Kirchhoff voltage law. Kirchhoff current law. Are you remember Kirchhoff current law? Summation of current equal to 0 at the node, let's say the node A. Okay, so, or in other words, we can say that current enter equal to current leaving. Okay, I equal to current enter to that node equal to current leaving, IR plus IC. So you can get I. So current through this L element. Is it clear? Okay. So next you need to draw the phasor diagram. So you have a current in phasor form. You have current IC, IR, and I. This is current in time domain. So in order to draw the phasor diagram, you need to refer to the current in phasor form. Okay. First of all, you can draw IC. Okay, you can draw VC. VC, V supply, angle minus 90. This is an angle minus 90. Okay, this is an angle minus 90. Okay, angle minus 90. And IC, angle 63. Then your IR, angle 153. And then your I, angle 100. Your I, angle 108.38 degree ampere. Okay, this is the phasor diagram. So you have to know how to draw the phasor diagram. Okay, so next, okay, we have an exercise. Then you can try this exercise. We have an answer, then you can try this exercise. This exercise, you need to determine or you need to find VT. This is a VT, voltage across capacitor, in the RLC circuit below. Okay, given Vs equal to 10 cos, let's say T. Okay, then you need to determine VT. Okay, just by using voltage divider rule. Okay, this is the answer. So you can try by yourself. Okay, this is exercise number 1. So exercise number 2, you can try. Okay, find the steady state expression for V naught T. For V naught T, if Vs equal to 64 cos 8000 T. Okay, this is our Vs. This one is Vs. This one is Vs. Okay, find V naught T. Okay, you can solve this circuit by using voltage divider rule. Okay, this one you need to apply voltage divider rule. This exercise you need to apply voltage divider rule. This is the answer for V naught. Okay, make sure you try this exercise 1 and 2. Okay, that's all for voltage divider rules. So next we will discuss about a current divider rule. Okay, first of all, we try to derive the equation of current divider rules. Okay, current divider rule basically is useful in determining the current flow through an impedance within a parallel circuit. Okay, let's say we have a current supply, okay, across a Z1, current supply connected to the Z1, Z2, Z3 until Zn in parallel. This one in parallel, in parallel. So how to derive the current divider rules? So first of all, we need to apply the KCL at this node. KCL, Kirchhoff current law. So I equal to I1 plus I2 plus I3 until IN. Okay, so by using Ohm's law, we can determine current I1. We have a voltage across Z1 equal to voltage across Z2. Okay, until voltage across Zn. Okay, because we are in the same node. Okay, they are in the same node. Okay, so V1 equal to I1 equal to V divided by Z1, I2 equal to V divided by Z2. Similarly to IN equal to V divided by Zn. Is it clear? So you can replace to this equation I1, I2, and IN. This is the way how to prove the equation of current divider. Okay, so by solving this equation I equal to I1 plus I2 plus until IN, so we can write V equal to, so because I1 equal to V over Z1, I2 equal to V over Z2, okay, we can factorize for V equal to, in bracket, 1 over Z1 plus 1 over Z2 plus 1 over Zn. So, in order to determine current I1, how to determine I1? We know that I1 equal to V over Z1. Okay, I1 equal to V divided by Z1. Okay, V divided by Z1. So we know that V, what is V? V equal to IZ, I times total Z. I times by total Z. Okay, so divided by Z1. So rearrange this equation. I1 equal to Z divided by Z1. Okay, times I, times total I. Okay, similarly to I2 equal to IZ divided by Z2. So Z equal to Z2 times I. So in general, we can write IN equal to Z divided by Zn times I. Okay, this is our Z. This is our Z. Okay. Okay. So Z in parallel, we need to inverse this one. Okay. We discuss in detail. Okay. Let's say we have a current in we have two impedance. Okay, we have a current supply to two impedance Z1 and Z2. So our task actually is to determine I1 and I2. Okay, we know that I1 equal to Z divided by Z1 times I. Okay, Z, how to determine total Z for two impedances in parallel? We know that when Z1 in parallel with Z2, so total Z equal to Z1 times Z2 divided by Z1 plus Z2. Okay, so divided by Z1 times total I. So by solving this equation, okay, by solving this fraction, and you can get Z2 divided by Z1 plus Z2 times I. Okay, which means that I1, your I1 equal to this equation. Okay, no need to know the voltage. By using information of Z and supply current, you can determine current through Z1 and Z2. So in this case, what we can summarize, I1 equal to Z2. I current through Z1 equal to Z2 divided by Z1 plus Z2 times I. That's the way how to remember. Similarly to I2, okay, we derive this equation Z, this is a Z, okay, divided by Z2 times I. So we can get this equation, okay, equal to Z1 divided by Z1 plus Z2 times I. Okay, in order to determine current through Z2 equal to the ratio of Z1 over total Z, Z1 plus Z2 times I. That's the way how to remember lah. Okay. Or in other words, we have another approach to determine current. So we know that voltage across Z1 equal to voltage across Z2. That's another approach lah. Okay, another useful current divider relationship can be obtained by taking the ratio of current 1 to 2 as follows. Because we know that V1 equal to V2, then V1, this is a V1, I1 Z1 equal to I2 Z2. So I1, okay, rearrange this equation. You can get I1 over I2 equal to Z2 over Z1. Okay, so you know that if you want to determine I1, you can get the relationship between I1 and I2. Okay, by rearrange this equation. If you want to determine current and given I1, you can determine I2. Okay, that's the relationship between current I1 and I2 based on impedance. Okay. Okay, so look at to the example, how to apply, how to use current divider. Okay, for AC steady state analysis. Okay, find the steady state expression for I naught. Okay, this is I naught. Okay, given n I1, this is I1, I naught. Given IS equal to 125 cos omega t. Okay, this is in this circuit actually is time domain circuit. First of all, you need to transfer to phasor domain circuit. Okay, given this one cos. Okay, so is is given, so you can convert to phasor representation. This is is, and then determine zl and zc, zl and zc, zl equal to j omega l, and zc 1 over j omega c. Okay, then you need to draw the phasor domain circuit. From time domain, you draw the phasor domain circuit. Okay, capital I1, capital I0. So this is your is. Okay, so what you need to do, you can apply current divider rule to determine I1 and I0. Okay, by using current divider rule, okay, first of all you determine the total Z. Let's say this is you combine, let's say become your Z1, this one you combine become your Z0. Okay, Z1 and Z0. Okay, so I0 equal to, if you want to determine I0, I current through the Z0, what you need to do, how to remember the formula, Z1, okay, this is a Z1 divided by Z1 plus Z0 times IS. That's the current divider. Okay, then you can get I0. Okay, this I0 you can convert to time domain. Okay, how to determine I1? I1 equal to Z0 divided by Z1 plus Z0 times IS. Dia terbalik sikit kan. Okay, then you can determine I1. Okay, then you can determine I1. Okay, try, can you calculate for I1? Okay, please try to calculate I1. Okay, I1 equal to Z0 divided by Z1 plus Z0 times IS. Okay, that one, that the equation of I1. Okay, when you sum up I1 plus I0, you can get IS. That's the way how to check your answer. Okay. Okay, so I think that's all for current divider rule. That's all the example of current divider rules. Okay, let's try this exercise. Okay, you can try this exercise. Exercise 3. Let's say you have for the given circuit, determine you are given phasor current IB. You are given phasor current IB 5 angle 45. Okay, this one IB is given, for example, IB is given 5 angle 45. The question is, you need to determine, find IA, IC, and VG, and voltage. Okay, given IB, let's say IB is given 5 angle 45, and then find IA and IC. Okay, you have this current. Okay, how to apply current divider rules and others rules for solving IA, IC, and VG. Okay, you try by yourself first. You can try first. Okay, number 2, if omega equal to 800 radian per second, write the expressions for IA in time domain, IC in time domain, and VG in time domain. Okay, so the next question, I add one more question. Let's say question number 3, draw the phasor diagram. Draw the phasor diagram for IA, IC, and VG. Okay, draw the phasor diagram. Okay, so that's all for current divider and voltage divider rules. Okay, so this is summary of our lecture. Okay, summary, voltage divider rule. Okay, voltage divider rule. Okay, let's say we have a series circuit. Okay, voltage supply connected to Z1, Z2 in series. Okay, so how to determine V1? V1 equal to, okay, V1 equal to Z1 divided by total Z. how many Z that we have in the circuit, Z1 plus Z2, Z3 until Zn. Let's say we have n impedances. Okay, V2, how to determine V2? V2 equal to Z2 divided by total Z times input voltage. Okay, so in general, we can write this equation, Vi equal to Zi divided by total Z times V. Okay, this is summary for voltage divider rule. Next, this is the summary for current divider rule. Okay, so let's say you have a circuit current supply connected to the Z1, Z2 until Zn in parallel. So how to determine current? This is the equation of current. I1 equal to total Z divided by Z1 times I2 equal to Z total divided by Z2. So in general, we can write In equal to Z divided by Zn. In equal to total Z, total impedance in parallel, divided by Zn. Total impedance in parallel, please remember. Okay, times total current. Okay, let's say you have n impedances in parallel. Okay, next, if you have two impedances in parallel, let's say you have a Z1 and Z2 in parallel, so your I1 equal to, let's say your I1 equal to, how to remember? In order to determine I1 equal to Z2 divided by Z1 plus Z2. If you have two impedances in parallel, times by I. So that's the way lah. In order to determine I current, this one equal to Z2. Similarly to I2, in order to determine current at Z2 equal to Z1 here. Itu dia punya perbezaan. Okay, so I think that's all for today. Okay, I hope you can understand current divider and voltage divider rule. These rules basically is useful for circuit analysis, either AC circuit analysis or DC circuit analysis. Okay, so that's all for today. Okay, Assalamualaikum warahmatullahi taala wabarakatuh.